The heavy burden of existence, the chain of survivors and reproducers. Here's an intriguing thought for you. If we trace your lineage backward, starting from yourself, we can establish an unbroken chain of survivors and reproducers stretching back for billion years to the very first life form that evolved in a chemical soup. This isn't just about your parents or grandparents. It's not even just about your Homo sapiens ancestors, anatomically modern humans. It's about everyone and everything, human-like and non-human, that lived in your lineage for millions of generations. They didn't just manage to survive until reproductive age. They also successfully reproduced, giving birth to offspring successful enough to reach reproductive age themselves. If this doesn't make your head spin, I can guarantee you haven't thought about it enough. Because consider this, for every successful chain that leads to each of us, billions of other chains broke at some point within that 4 billion year time frame. And for that reason, the individuals representing those chains are not with us today. Or consider this, if any single individual in your lineage at any point during that 4 billion year span had been in the wrong place at the wrong time for any reason, and died before reproducing, your chain would have been broken and you wouldn't exist today. It's not just about individuals. An entire species going extinct at a certain point prevents all potential descendant species that could have evolved from its lineage millions of years later from ever existing. All of this reminds us of the profound biological importance of two phenomena, survival and reproduction. Biological versus Crowley. You can choose any life purpose you desire. I will excel in science. I will be a devout person. I will paint or make music very well. I will be the best at my job. I will live as a good human. I will help others. These are all wonderful goals. However, no matter what you declare your life's purpose to be, simply by being a biological organism, there are two purposes automatically set for you: to survive and to reproduce. If you, as an individual, choose to opt out of either of these, the species as a whole is affected only to a limited extent. Unfortunately, as we hear new examples every day, people end their lives, or, putting suicide aside, do people die every second globally. Likewise, not all of us choose to have children, but as long as these remain limited, they pose no threat to our species. However, if as a biological organism, us species, all or most of us, were to abandon either one or both of these fundamental life purposes, the Homo sapiens species would be wiped off the face of the earth in a short time. On the other hand, failing to achieve the cultural goals I mentioned earlier might make life boring, empty, or meaningless for us, but it wouldn't threaten the future of the species as much as abandoning the biological imperatives. Therefore, no matter what purpose you choose for yourself, you must first fulfill the biological purposes, the drive to sustain your own existence, made possible by survival and reproduction. All our other preferences are secondary. As you can infer from this, every choice you make doesn't just affect your own life. It also determines what will happen to a lineage that has continued unbroken for 4 billion years. For instance, if you were to die without reproducing for any reason, you wouldn't just be making a decision about yourself. If you have no siblings, you would be severing a lineage that might otherwise have continued for another 4 billion years. Are you starting to feel the heavy burden of existence on your shoulders? Animate versus inanimate. Let us clarify something Terms like survival instinct or reproductive instinct can be misleading. At least in the ethological sense, the scientific study of animal behavior. These words are meaningful only for animals with a nervous system. Of course, this isn't just about animals. It's about everything that is alive. Considère-t-il could speak of lineage avec that cannot survive and cannot produce copies of itself. The entire existence of a rock consists of the changes of a single object over time. A rock cannot produce copies of itself and can break apart, but those fragments cannot transform into copies of the original rock. Couldn't this be different? Couldn't we imagine a universe where rocks produced copies of themselves? Of course, we could. But within the confines of our current universe, what we call living things are objects that can actively sustain their own existence. What we call inanimate things are objects that passively continue to exist, left to the mercy of environmental processes. What I've described so far also answers a very fundamental question about the evolution of life. Sometimes people ask how the first life knew it needed to survive or reproduce. They didn't know. The problem begins when you use the word know. The first life forms didn't have nervous systems or brains to exhibit what we call knowing. There was no situation where they knew things and acted accordingly. We give various names to things happening around us and divide them into artificial categories because thinking in categories is easier for us. Perceiving living and inanimate things as different forms of a single type of existence is somehow very difficult for us. However, objects that are part of this universe can have very different physical and chemical processes. For example, the geochemical processes that form a rock are a good illustration. The physico-biochemical processes that make biology possible are another. Don't let the difference between these two mislead you. They don't gain these properties because they are living or inanimate. They already have certain properties, and we categorize them based on those properties. For instance, we know all the steps of the process by which a rock, originating from magma, reaching the surface due to the Earth's core temperature, attains a magnificent mass and then breaks apart to return to magma. You can see a step-by-step example of this. But because this is a more passive process, we call the rock that is part of this process inanimate. I suppose if a rock could produce copies of itself and react differently to environmental conditions, it wouldn't be so easy to call it inanimate. But because the overwhelming majority of objects in the universe have a more passive existence, like a rock, we call them inanimate. Even now, the distinction between living and inanimate can sometimes blur very quickly. For instance, is the planet Earth as a whole living or inanimate? At first glance, it seems inanimate. But when you look at the planet's reactions to changing conditions over long periods, you begin to see that it's not so different from a single cell. For example, the Gaia hypothesis argues that Earth is a living organism. Another point that blurs the distinction between animate and inanimate is the origin of life itself, or abiogenesis. In light of our modern biochemical knowledge, our best estimate regarding the origin of life is that the structures we call living emerged through the chemical evolution of molecules we would term inanimate. If you look at the coacervates, which we refer to as the first life forms, they weren't strictly composed of self-replicating chemical molecules. You probably wouldn't even call them alive. They were more like microscopic, mobile blobs of fat that followed chemical gradients, incorporating nearby molecules into their structures to become more complex. But the biological evolutionary process, which began with their ability to replicate themselves through division, differentiate slightly in the process, and for the fittest of these differentiated copies to produce more copies in their environment, led to the evolution of the more complex life forms we are familiar with today, continuing that lineage to the present. In summary, what we call living is a name we give to objects that can preserve their own existence and produce copies of themselves. Things this, by définition, we call living. Look, you can even lose characteristics that seem vital in the evolution of life. For example, you can lose your arms and legs, as in the evolution of snakes. You can lose your eyes, as in river-dwelling tetra fish. These are not major problems for the evolutionary process. But if you lose your drive to survive and reproduce, your lineage ends. Since such a lineage cannot continue, we couldn't call anything with such a characteristic living. This is precisely why living things do not survive and reproduce knowingly or willingly. We simply call things that possess these two fundamental characteristics living. And because all life is descended from a common ancestor, we see the inherited drive to survive and reproduce in all living things that exist today and those that lived and perished in the past. Biological imperative and the nervous system. Indeed, this phenomenon of self-preservation is ingrained in many different layers of biology. Multicellular organisms not only try to preserve their existence as a whole, but the individual cells that make up the organism also strive to preserve their own existence. In fact, when the biochemical continuity of being an organism breaks down, some of these cells enter uncontrolled proliferation pathways, and we call this cancer. Cancer is nothing more than a series of cells declaring independence from the body and striving to sustain their own existence. We also see this phenomenon of self-preservation at the level of social groups. A large majority of the conflicts our species experiences internally stem from perceiving another group as a threat to our own existence. However, if we pause to think, we would see that in modern times, very few external factors are capable of completely annihilating us. But that fundamental anxiety, that primal fear, leads us to make mistakes. This is why, for instance, we overconsume. This is why we exploit the resources of others. This is why we oppress those we perceive as the other. And this is why we build socioeconomic systems that allow us to justify such exploitation by sheltering behind simple biological impulses. Yet, probably not. Our civilization already possesses the power to easily overcome such a fundamental level of existential struggle. Finally, we see that this phenomenon of self-preservation is embedded in the nervous systems of a vast number of species, from the simplest organisms to the most intelligent animals. Let's put aside our reproductive impulses and look at the survival drive. Can a Habitus elegans worms have only 300 neurons? For comparison, we have about 86 billion neurons and an equal number of glial cells in our brain alone. But these 300 neurons make it much easier to study that simple structure, and by looking at it, we can gain insights into the human brain. A study conducted on the brain of this worm aimed to track when the worm preferred to search for food and when it preferred to stay put. Although this sounds like a simple choice, a worm's survival depends precisely on these preferences: find food or stay put. In their study, researchers found that the firing of a single neuron, named NSM, determined the direction of this fundamental instinct. If it fires, search for food. If it doesn't fire, stay put. They then developed an artificial intelligence algorithm that tracked this neuron and 3 other neurons they found to be related to the issue. By looking only at the firing of these neurons, they managed to predict what the worm would do with 95% certainty even before the worm made that movement. What do you think this tells us about the free will of humans or other animals? Based solely on these experiments, can we say that humans are nothing more than survival and reproduction machines, or is there more to being human? Please don't forget to share your thoughts with us in the comments.